All right, let's get going. So quick bit of introduction from us. I'm Tony and I've been working on mastery for probably 6 years now, ever since I discovered the concept and how useful it was for teaching my own children. I thought, well, this is something we should be applying to science. It's a kind of philosophy that says we don't want any child to fail because they haven't had enough time to learn, or because we haven't tried enough different things to make sure we have got over the obstacles they might face with learning. And that's the philosophy, and the system is what's taking forever to create, trying to put into place everything that kind of fits into a line that says we want them to be able to understand and apply and analyze. How do we get there? What are the steps? How do we sequence the curriculum? How do we create the resources? What kind of book do they need? What kind of practice do they need? And what sort of diagnostic assessment would help? And slowly, I think we're assembling these pieces together. And it's slow because we have to apply a lot of research and understand it ourselves. And the benefit is that as we develop something, let's say the latest thing is our textbook for year 7, as we learn how to do that, we like to share what we've learned in these webinars so you can apply it yourself. And that's what we're up to in these 2 webinars, which we've called Beyond Rosenshine, because I think they fill in the gaps that direct instruction, you know what to do when it comes to chunking up things and checking for understanding. But what is it the students have to do to make sure they get the benefit of this instruction? And that's what we are trying to deal with today. And I hope this will give you a lot more practical strategies to take away. So that's me, Gemma.
Hi everyone. So I've been working with Tony on Mastery Science since it started, and then before that we've worked on various projects together. And before that I was a science teacher, secondary school science teacher.
Great. So let's get started, and welcome to all of you. Please feel free to interject with the chat, and if you're very brave you can even speak, but certainly put some comments and questions in the chat, and every so often we will stop and address them. So really, if there's something that doesn't make sense, please do say. That, after all, is part of direct instruction, and we like to as we say, eat our own dog food. So let's get started with a bit of an engage for you. So imagine this scenario. Teacher says, yeah, good lesson, answered all my questions. But then a week later, oh dear, they failed that mastery test. And that mastery test was all about understanding and application. So, question for you, what could have gone wrong? Answers in the chat. Got some answers now. So good. Recall questions in the lesson. Right, not like the ones that they were tested on later. That's a good point. They couldn't apply. Sure. I wonder why that is. Okay, some other good answers. Actually, the evidence of whether students had understood the lesson only came from 2 students. Absolutely. Link between the knowledge and the application. Sure. And this idea that maybe they were doing well in the lesson, that's short-term memory, but that doesn't tell you it goes into long-term storage. Great, all good answers. And we want to add another answer to that one that's relevant to today, which is maybe, right, and there's we're getting into the terminology here, germane load, absolutely. That's the word we're gonna come up with a lot, germane load, which means, are they processing what they've been told enough? so that it does go beyond the short term into the long-term store, and it's also connected in such a way that can be applied. And there's a very simple word that kind of is bandied around in the literature, and this is meaningful learning. So on the left, we have that the students are learning in a superficial way, so they can remember stuff, they can recall stuff, they can do questions that are similar to what they've been taught. But when it comes to something quite different, then no. That's because, as you may have seen with our previous webinars, there's this concept of organization of knowledge. If your knowledge is all stored in a fairly, random way, not connected to the big ideas, then it's quite hard to find what you need. And that means you can't answer questions where they have to say, well, this is an unfamiliar situation. What's the concept being used? And because your knowledge isn't organized, you can't figure that out. But if you've learned in a different way, which we call meaningful learning, and we'll explain, then your knowledge is organized around the key ideas. And that's what you need to be able to recognize a situation, let's say some unfamiliar physics problem. You recognize what concept is underneath those superficial details. You recall all the information, and then you can solve the problem. And this is pretty much accepted in psychology, that is what we need. But how do you get there? We'll see. And this is what we're going to do tonight. We're going to look at the 8 activity types that help students make sense, learn meaningfully in a way that they can then later apply. And let's go a big step further. So we're not just giving the children the fish, we want to teach them to fish. So they learn the strategies they can use themselves independently. And some of them are exactly the things that really good students do spontaneously or have learned to do over the years. So this is a really good thing in terms of thinking and metacognition. All right, recap. Last week, we looked at the basic idea that led to this multimedia approach, which is cognitive load theory. And to remind you, there are 3 types of load that psychologists believe are important. And the first one is the actual nature of the material. If it's complex material, there's a lot to process, a lot of information to keep in your short-term storage. But you don't necessarily want to overload students, so you try to simplify as much as you can and chunk it up so they don't have too much to cope with at once. The other type, which is the bad type, is the extraneous. That's the stuff that distracts the students from what they have to process. So for instance, if you put in unnecessary diagrams or language or anything really that doesn't need to be there, you are wasting their limited processing power. That's what we did last week on the left, but on the right is what the student has to do with that information you give them. It's kind of like the processing that needs to go on. And the word that Richard Mayer, who's the psychologist behind this multimedia approach, uses is generative activity. So it's not just passively, putting the information into your memory. It's actually doing something, creating better connections between the knowledge that's in your memory already and the new information. And that's what we're going to look at strategies to help. Bit of a warning, as last week, this is research and you can't just say, oh yes, that gives me a silver bullet. I'm going to do these 8 every lesson and that will, cure everything. Because there's a lot to do with how you do them, when you do them, and understanding those nuances is what makes the difference. Secondly, I hope you'll realize that this has got nothing to do with motivation. All these theories are cognitive, an ideal student working in their brain in the best way possible. But that doesn't tell you anything about engagement, whether they actually care enough to learn meaningfully, or whether they're interested in what they're doing on the weekend. And so they're only giving it a superficial amount of attention. So no matter what activity you give them, if they're not fully engaged, then that won't work. And finally, in case it does look obvious, you know, we're going to use words like summarize or draw, and you think, well, yes, obviously I've always done that. I've always got them to make posters. Don't assume that just because the words are familiar that you can just sort of absorb them into what you think. I'm pretty sure I've changed my ideas, and I imagine Gemma has, about what these activities look like in practice on the page from what I used to think. So hopefully they will give you something new to update your models of pedagogy. So what are those 8? They look quite straightforward, and here they are. They're basically all ways to promote deep or meaningful learning. And these categories are ours, they're not Richard Mayer's. This is going beyond the research here, because we think it helps us to categorize them into 3 kinds, and we're going to deal with each one separately. So on the left, we are calling this concrete. This is physical. This is engaging in some sort of physical activity with objects, doing something, not just in your head. So enacting literally means using manipulatives in maths, or playing with objects in physics, or being the particles or the electrons in a simulation. This is whole body stuff, and I'm sure you don't need telling why that's a powerful way to learn. And then something that we're not going to cover tonight because it's so much meat and drink to you. This is learning by teaching. We all know that the best way to learn something is when you have to teach it or give a webinar about it. So that's the category we're going to come to in the end. We're going to start with the middle one, pictorial. That means using the visual channel. And there are 3 techniques here, which is mapping, drawing, and imagining. We'll do those first, and then we'll do the ones that are more verbal or abstract, using words. And this is to make summaries, to test yourself, and to explain things to yourself. And let's go straight into why we think, first, how do they fit into our model? Because I want you to know what we're kind of adding to the Rosenshine piece. So the basic model of direct instruction is you set the scene, you introduce, review what's been done before, what they already know, and then you teach the new stuff by modeling, demonstrating, explaining, giving examples. That's your intervention. And then you follow up by some practice and checking of understanding. And it's the immediate, what do students do after you've explained to them? That's where we're going to put this. So we're not just necessarily going to give them questions to do. We've got these 8 different things that they can do with all that information immediately to make sure they process it enough. And I think this model is quite useful because there are various levels at which students can engage with the information, right? And I guess we sometimes fall into the trap of going to the bottom. So the students are listening, like you're listening, but you might just be listening and not processing the information, right? And for various reasons, because you're just assuming that it will go in and something will change as a result. The students might not know how to process the information. You're not giving them anything to do with it, so they might just sit there. And that kind of passive, receptive learning or listening or reading is pretty ineffective at meaningful learning. We know that. That's the least effective kind. Then moving up one level is where you do something with that information. Perhaps you highlight what you read in the text. People love to do that. Or you repeat it back by answering some questions that are basically take the text and stick it into the box. That kind of thing is better. You are active, but it's actually not good enough. It's not good enough to, for instance, allow you to apply knowledge, because it's pretty obvious that you're not doing that while you're learning it. You are just simply trying to rehearse it and put it into the store somewhere. It's that third level where we're working at today, which is called constructive. So it's going beyond active, generative or constructive knowledge building, which means you've gone beyond the information. You've had to connect it together, and you're going to connect it into what you already know. And all these strategies aim to do that. And let's be honest, this is not the best possible way of learning because it's all in your head. You can do even better than that if you move out into the world and you have a kind of social, interactive environment to learn in, provided that it's obviously focused on what you're trying to learn. Because you have a dialogue with someone, you can explain things, you can listen, you can think it through, and then you can say what you think, and someone else can say, well, that's good, but maybe what about this? So that's sort of interactive teaching as compared to just doing something on your own. And this model has been verified, and it does seem to work. So I hope that gives you a kind of, what should we say, justification for trying these activities or trying discussions rather than just getting kids to read and listen. All right, so pictorial strategies. Let's just describe the three briefly, and then Gemma will give you some examples. I will pause briefly in case there's any questions before we get into the real guts of this. Gemma. Anything?
No.
Okay, so the first of our pictorial or visual strategies is making some spatial representation, putting information into, you know, different places to show what the relationships and the connections are. And the reason why doing this works is because information has to be connected together. I think I actually missed the slide out here, Gemma. I'm going to go back. That's the slide I missed. So the reason why all of these activities work, according to Richard Mayer, is because the way we process information involves these several stages, which we explained last time. This is a recap. So we have two channels. You have images, pictures going into your visual channel through your eyes, and you have sounds, which make words, going through your verbal channel. And they get processed initially separately, but then you have to organize them and integrate them together and also connect them with what you already know. And that is essentially how information gets transferred into your working memory and then into your long-term memory. It's a simple model. The three parts which we're going to come back to again and again are selecting, which means paying attention to the important stuff, organizing to find some sort of pattern that connects that information together, and then integrating it all and with what you already know. So mapping is exactly that, isn't it? It is about making connections on the page. So it ought to be a good way of learning because you're making the students go through those three stages. But it tends to work best when the content has some spatial features. There's not much point in making a map of something that's purely a set of, you know, verbal ideas. And also, we have to recognize that if you ask students to do concept mapping and they've never done it before, they're probably not going to do a very good job. So it requires them to be able to use the format that you're making them map in. Let's give you some examples in a minute, but we'll just explain the three kinds first. So drawing is more free form when you actually make an illustration yourself, let's say of a cell. And that's about selecting the information to put into your drawing. And you also have to think about, you know, what goes where and think about your prior knowledge. So it's going through similar processes as mapping. And you would use that when you have some visual structure like a cell, because you want to know where everything is, the locations. But there are some pitfalls. When the task is quite difficult, let's say somebody says, draw, you know, a neuron from scratch, the students will struggle. So it's not a good idea to give two open drawing tasks. You have to scaffold them and make sure they're focusing on what they need to. And the third one, probably we're less familiar with this one, but it's equally valid. The idea of creating a mental image rather than on the page. because again, you have to put things together and organize an image. And of course, in sports, this is a very big part of training. And it works particularly well when the students have the prior knowledge, because obviously if you don't, you can't put together the bits of the image, and you might need some training. So these are the 3 pictorial techniques. How do we use them? So the basic idea that we've been following in trying to determine which activity to use when is we ask a series of questions. We start with the understanding. Excuse me. So there is an idea we're trying to communicate. Think about that and how you would have done that. So sexual versus asexual reproduction. What kind of schema, by which we mean mental structure that you want in the long-term memory, what kind of schema is it? We call that a classification schema. That is actually from reading research that breaks things down into different kinds. You've got concepts and principles and processes, and this is a classification because we're trying to group reproduction into 2 categories. So that's the idea. We're trying to show similarities and differences. What is it we think is difficult for the students to grasp? These 2 things. They're different mechanisms, but they have various things in common. And that is really the crux of what we want to communicate. And we want to support students to do that with an activity. What should we use? We've got 3 of those activities. Which one would work? Well, we think mapping would work really well there, because we know that you can construct a simple table, and on the left we can put some of the features of reproduction, and then we can give students bits of the table to fill in so that they can see the compare and contrast. So we've scaffolded it to make it a modest cognitive load, but we've focused it on the classification exercise so that they can really make sense of the differences. So that's how we would tend to use these activities in practice. So let's get Gemma to show you some real examples.
Okay. Okay, so I'm going to show you some examples of what we've done, how we've used these activities, focusing on our textbook, Understanding Science. So this is one of the spreads on specialised animal cells. And next slide. So if we have a look at one small section of that spread, which is about nerve cells, we're thinking about what kind of schema then do we want students to build up. So Tony talked about before, the reproduction one was a classification. This is a different type of schema. So if you click, Tony, it's going to be animations, that's it. So sorry, go back. Okay, no. That's it. It's just the answer I want at the bottom. That's it. So we're saying that this is a structure schema. So a structure schema, we're looking at the location of the cell in the body. So we've got an image there where it is, the features that the cell have got, and then the functions of those features. So we're looking at how is that cell adapted to its function. And this is a structure schema that we're trying to get students to build up. So if we go on to the next slide. So when we've, in Understanding Science, all of our generative activities, well, most of them are at the end in the review question section. So we expect students to read through that information and then have a go at the questions then to really build their deep understanding. So we've got 2 questions here that could have come up. I want you to think about, and you can put in the chat, which of those do you think will best support that understanding of the structure and function of the nerve cell? So if you just put A or B in the chat. Okay, great. We got a lot of B's. You click, Tony. So question B, and that is a drawing activity. So if we just put A, how the messages pass from cell to cell, what is likely is students will just look in the text and copy out something that they found in the text, and they won't really understand what is going on. However, if we ask them to actually draw arrows to show that message going from cell to cell, they're building a deeper understanding because they're developing the idea of why the branches are there. So they can see that the branches join the cells together, and then the message can go along the branches into the next cell. So they're building a deeper understanding using that drawing activity. And as Tony said before, we scaffold where we can. So we are not asking them to draw this out of their memory. We're giving them a diagram, and then we're just asking them to do a rough sketch. So we're not testing their ability to draw a nerve cell. We just want to test that understanding. Do they know the function of those branches? Okay, next. Okay, so let's move on then to imagining. So we're looking at what happens during melting. So the understanding we want students to get here is that when you heat up a solid, the particles start to move around more. So if we have a look at the review question, then that goes with this. Yep, so this is what we came up with, and this is an imagining task. So imagine a group of marbles in a tray representing particles. Now imagine gently shaking the tray so the marbles move. To explain how this represents melting. So we're actually thinking about what happens to particles in a solid and linking that to something concrete that can actually imagine doing, rather than imagining these abstract particles. If you click again. Okay, so why was imagine chosen for this? It's basically so they can build up this mental model, this mental image, and build up that understanding of melting. Okay, that's me for now.
Thanks, Gemma. So now we go on to the next category. We call these abstract, basically verbal ways of helping students make sense. The first one of the group is summarizing. This is perhaps the most difficult one of all. Putting things into your own words, like writing your own notes. And of course, in order to do that, you do need to select, organize into sentences and integrate things. So it's a perfect way of processing the information. However, it's really hard for many students to do. So probably we need to do it with only a very small amount of content at the beginning. And we want to do it with content that isn't spatial, that doesn't benefit from being organized in a diagram or something, because then we'd use a different strategy. And we really need to scaffold this process if they haven't had lots of experience at summarizing. The second one, which is probably the thing that you most use, self-testing, which basically means answering questions. So you'd think, well, yeah, I do that all the time, but there is a little wrinkle here, which is that if you want students to be able to transfer or apply the information later, then it's been shown by the research that pure retention questions, recall questions, aren't the ideal. So what we want is for them not just to sort of rehearse and remember stuff, we want them to process it more deeply. And that means actually giving questions that have some degree of transfer in them, right? So if you just have fill in the blanks and explain the stuff that's on the page, that doesn't qualify as transfer. And that's therefore less effective as a way of testing. So we know retrieval works. We know that's a very strong psychological principle, but we aren't just interested in memory here. We're interested in being able to apply it and go beyond. And so the things that make it work effectively are, yes, transfer questions while you're teaching. I know it sounds hard, but that is the way to get them to move up their thinking. And secondly, when they get feedback, right, because they're just answering the question without knowing, doesn't necessarily allow it to be processed as well. And as I've said, if the practice is similar to the kind of test you want them to take, then you get the best outcome. The third strategy we'll look at is a little bit more complicated, because we're not just saying ask a question. What we're asking the kids to do is to ask themselves a question. And the question we want them to ask is, does that make sense? I wonder, why did he say that? Or why does the text say that? How did they get that step? So it's getting students to ask their own questions to clarify their understanding. And that's called self-explaining. And it's been proven in a whole wide range of situations, because it is literally, you know, processing on speed here. You are doing a lot of work to try and sort out what the material means and integrate it with your knowledge. And it's particularly useful when the content is complex, because then you do have to figure it out. You can't just say, okay, I know what he's saying. There's a lot of work to be done. So explaining to yourself is ideal, especially when it's also visual and diagrams, because you've got to kind of interrogate the bits of the diagram and figure out, well, there's that bit of the diagram, there's that sentence, how do they make sense together? And equally, when it's likely students are going to form misconceptions, you don't want them to take what you say verbatim. You want them to think about, hold on, so he's shown me one force of a, I know, cat sitting on a sofa. There's a reaction force up on the cat. Does that mean I've got to think about, you know, furniture and animals when it's this force? Or what else does that apply to? So the more work the student's doing, the less likely they are, if they're guided, to form the misconception. And yes, you have to show students how to do this, because many students aren't ready or prepared to go to this level of depth. So those are the three strategies. I'll let Gemma take you through what they look like.
Okay, so we're going to have a look at another specialised cell. So red blood cells. So you can see it's similar to the nerve cell I showed you. We're looking at location in the capillary and the features and their functions. But let's have a look at using a different type of activity then to assess this understanding. Tony, next. Okay, so we've got a question here. Red blood cells are specialised animal cells. State the function of a red blood cell. So we're looking at how can we improve this question, because at the moment that is just a recall. So we click. Okay, so what we've done here is we've changed this into a summarising. That's fine. A summarising activity. So we're adding two more parts here, which is asking them to think of what special features the red blood cell has got, and then explaining how those features help its function. So linking the function of those features basically to the function of the whole cell. So we're getting them to summarize really the how a red blood cell is adapted to its function. So in a GCSE question, they might just get that as a summarizing activity. Just that statement, explain how a red blood cell is adapted to its function. But as this is for year 7, we are scaffolding this skill of summarising, and we're breaking it down into these 3 parts so they could go through those 3 parts and get a full summary of a red blood cell function. Go on to the next. Okay, so question for you again here then. So we've got an activity here about strange looking cells in your windpipe, and the students being asked, how do cilia help cells do their jobs? They're being introduced to these hairs on cells called cilia. They haven't come across them in the spread so far. So what type of activity is that question using? So if you think it's A, B or C. Okay, to reveal the answer, Tony. Yeah, so you all put B, it's self-testing. So we are asking students to transfer their understanding of specialised cells to a new situation there. So in doing that, we are helping them then when they come to do an assessment on this, to show their understanding, that they have got a deep understanding, that they can talk about other adaptations and how they help other specialised cells. So they're transferring their knowledge. Okay, next. And the final one that Tony talked about then was self-explaining. So if we move on to a chemistry spread here, we're looking at a separating technique. So separating different solids like sand and salt. And we teach this is a process schema. So we're teaching it in a series of steps. We click a few times, Tony, we'll bring up the close-ups. Okay, so we've got step 1 here, dissolve, and then step 2, filter. And if you notice, there's some, and step 3, evaporate, there's some questions there in speech bubbles that we put into the margin. Now that's to help students develop their self-explaining strategy. So as Tony said, we really want students to be able to stop after each section and think, oh, well, why did that happen? Or why did they do this here? What's happening? So to help them, we're putting in these questions which are prompting those kinds of thoughts. So it's a scaffolding of sorts, and it's training students to start thinking like that. So as they get older and GCSE books, they won't have these types of questions. It helps them develop that skill. So if we click again. So we're thinking, well, why is self-explaining used here? Well, it's just pausing between each step in the process and sparking that self-reflection. And it's given a bit of a pause between each step so they can think about why that's happening in one step before moving on to the other. So this self-explain is really useful when you're trying to explain a process. Okay, that's it, Tony, over to you.
Thanks, Gemma. So now the final category. These are, well, it's just one actually, one concrete activity. And we call this, well, the research calls this enacting. This means using movement or physical objects and interacting with those. Why it works, because we think, although this is a fairly, less researched area, that physical interactions produce very strong, concrete, embodied, like kind of taking it all in through all your senses, and because your body kind of is involved, you get a very strong representation that can be processed and put into your long-term storage. And it works particularly well when it's then turned into something abstract. So, for instance, the fact that you've picked up objects and you've done an experiment doesn't automatically mean you learn anything. And we know there's a bit of a backlash against experimental work for that reason, that kids are having fun, they like it, they're doing stuff, they're physically active, but they may not be very cognitively active and making sense of what they're doing. So you do have to kind of take that experience and turn that into an idea. That takes some skill, and we've become quite good at that, I think, because as I'm going to show you, there is a simple model that you can remember to make that easier. But if you don't do that, then it's like discovery learning, and the students may not discover very much. So guidance is critical, and if they're doing a simulation, you've probably tried simulations where the students have run around the class acting as some electrons or particles, and probably remember nothing about electrons and particles and everything about bumping into things and having fun and not working. So this is a great strategy, but has to be managed very carefully. So here's the example.
Okay, so in this example, we're going to look at the idea of natural selection. So this is something that some students find quite difficult. And we classified this as a process schema. So there's certain steps that happen in this process. So we're going to have a look at, I want you to think about really, how do you teach this understanding? And we're going to have a look at some of the things that I've come across, and then we'll have a look at what we did in Complete Mastery. If we go on to the next slide. So this is one thing I came across. So it's a page in a textbook, and it explains natural selection. It's got a nice flow diagram there, which is showing the steps in the process. But I want you to then just think about, do you think students will understand the concept if they read that and then they answered that question there? So if you want to type something in the chat, we'll have a bit of time for you to do that and have a think. Okay. All right, so we've had some answers there. Okay, so the main points were that it was quite wordy. There was no diagrams there. Diagrams might have been better to show the content. Okay, information overload. So if we have a look, Tony, at what we thought. Okay, so I thought the activity there probably wouldn't be great then at promoting deeper understanding. So the actual activity was describe the process of natural selection. So it was an abstract activity of summarising. But the problem here is that I don't think students would be able to come up with a very good summary from this information. Not only is it quite difficult to interpret this information, but they've got no scaffolding in order to describe that process. So it'd be very difficult for them to form any kind of understanding. They would probably just regurgitate what's already on the page. So if we move on to another activity. Okay, so this is another one that I found, drawing a storyboard. So they're again introduced the steps of natural selection, so probably pretty much like the page I showed before. They're told the steps, but this time they're asked to create a storyboard to show how polar bears may have evolved by natural selection. So they're going to draw a picture to show the steps and then write what's happening in the bottom. So do you think that activity will help them understand the concept? So what do you think? Okay, let's see what we think then. So I think the general feeling was it's better, but there are still some barriers there. So if we click. Okay, so we're going on to a different type of activity here. It's actually drawing. So we're asking them to draw a diagram or storyboard to show what's happening. But is that really the best activity to use to help generate that understanding of natural selection? And as some of you pointed out, there is a barrier there. Some students might say they can't draw, and they'd be more focused on the actual drawing than developing the understanding. So possibly better, but still not great. So let's have a look at another. Okay, so this is a classic one that maybe some of you use something similar. So it's a simulation game, and students are asked to pick up different sized beans with different utensils. So they're carrying out a simulation to model natural selection. So do you think students will understand the concept this time? Any ideas? Okay, yep, some good points there. Let's see. Yeah, okay, yeah. They need to understand basically what they're doing. Tony, if you'd like to click and we'll see before. Okay, so this is enacting. It's an abstract concept, but we're linking it to an actual concrete activity that students are involved in doing. So in that regard, it could be a good generative activity, but there are issues, and you identified quite a lot of the issues there. It's very complex. The instructions are long. So some students are going to be more worried about the instructions and how to carry out the game rather than actually forming an idea of what's going on and what it's modeling. So these types of things, you have to manage it really well. And it might not be so good for younger students. It might be better for older students where they can process the actual model, how to do it and link it more carefully. So it could work well, but it would take quite a lot of management to do that. So there are pitfalls with that one. So if we move on, Tony, and I'll show you what we did in complete mastery. So we did think that enacting was the way to go. So we stuck with that, but how is this better then? How is that better than the bean game before? So Tony, if you'd like to click, we'll move on. Okay, so it's still enacting, but it's a lot more simple. So it's easier for students to do and to see what's going on, and it's easier for you to manage as well. So in this case, students themselves took an active role. They acted as different organisms and each moved in a different way. And the task was that they had to collect food. So obviously the walkers are going to be more successful than the jumpers and the hoppers, and then the walkers would reproduce. And after every round, you would count up how many of each organism there were. So they're actively taking part in natural selection and they're experiencing selective pressure themselves. And as they're doing it, then they can build up an idea of natural selection. So we're not telling them this is natural selection, this is what we're going to model. They actually take part in a simulation, begin to build up that idea themselves. Now, in order for it to work, though, there are some conditions. So first of all, you have to be very clear with students what exactly they're doing, maybe stopping them throughout the simulation, getting them to reflect on what's happening and why and what changes are being made. So to make sure that they actually understand they're doing the model and their understanding is more focused on the actual what's going on rather than how to do it. If we move on. And then a really important stage afterwards is we don't want them just to remember, oh, that's the lesson where we all walked around or jumped or hopped, as Tony said before. We want to be able to link that to the abstract. So this is the important stage. First of all, you need to, well, we said before, natural selection is a process. So we're going to go through each of the steps in the simulation first of all. So we had three different creatures which moved differently. So we recap what happened in the simulation. And then if we go on to the next slide. And then we link that to what happens in real life. So in real life, we have variation in organisms. So in this case, we're trying to explain how dwarf elephants evolved. So we've got variations, some are large and some are small. So it's really important that you link the abstract to the concrete after they've done the simulation. Okay. Next. Okay, so a little bit of a generative activity for you now. I'm going to have a go at spotting some of these activities. So here's another spread from the textbook about non-contact forces. And if we zoom in to the review, so what type of activities can you spot here? So I should say that number one, we always start off with a simple recall question just to start off easy. So don't take any notice of question one. So it's just 2 to 6. So if you just put in the chat, the number and then what type of activity you think it is, and we'll see what you come up with.
So let's just have a couple of answers for 5 or 6, and then we'll summarize. Otherwise, we might set a Guinness Book of Records for the wait time.
Okay, should we go through them, Tony? On to the next slide, and we'll reveal.
Sure.
Okay, so you'll have to click through, I think. Okay, yeah, so number 1, we're not counting that one. So let's see number 2. Okay, so number 2 is drawing. 3 is actually summarizing. So we're asking them to describe the difference between contact and non-contact force. 4 is a mapping. And then 5 and 6 are both self-testing. So they're application questions, transfer questions. Great. Okay.
So thank you very much. And that basically completes all our input. Before we finish up, how about you tell us anything that you're not too clear about, any ideas, what's useful, what you're going to take away, which activity would you like to try most that you don't currently use? We'd love some feedback. Does it all make sense? So you can use all these in your explanations, worksheets. If you want to get students to read parts of textbooks. So we're getting some comments here, and before we finish, we would like to say it's quite useful to keep the chat open for a while so you can talk to each other and share things that you like. This is the end of our series. We only decided to have 2 of these to set out the basic idea of multimedia theory. You can see we've applied it in our books. We love it a lot because it makes the process of designing activities much more, how should we say, straightforward for us to decide what works where. And we hope it will allow you to select good resources and perhaps improve your PowerPoints and worksheets and experiments and all these kinds of things that you do every day. And that's basically it. If you want a look at some of these things, then please do. I'm about to release the webinars on video if you missed any of them. And if you want a sample of the book and you weren't sent one already, because I've sent quite a few out, then I'm going to send an email to everybody tomorrow, because you can still claim your free sample. And that's it. Thank you so much for attending and enjoy the rest of your term.
Bye everyone, thanks for coming.